All right, we've started recording, and practice quiz problem number 1. 7 out of 12 people believe in limiting handgun ownership. What percentage believe in limiting handgun ownership? Thirty seconds more. Okay, so on this one, it is, we make a part to whole fraction, which is kind of natural for this. 7 out of 12. But then we convert that. We go through all the different forms right here. Now punch this into my calculator. 7 divided by 12, I get 0.58, and 3 keeps going forever. And then this is 58.33%. And if you just gave me 58%, that'd be fine. Or how many 3s you want to give me, any of that's fine. Okay, so it goes from fraction to decimal to percent all in one problem. Kind of puts everything together there. All right, do number 2. 187 out of 535 people at the conference left early. What percent left early? Thirty seconds more. Okay, once again we do the part to whole. Punch that in our calculator. I get 0.34953, so on. And that's the same as, move the decimal 2 places to the right. I'll round off to 35%. Alright, and if you can give me feedback on those 2 problems, and also I'm going to put my document camera, and alright, tell me if you hear any buzzing noise from my document camera.
It's very subtle. I can barely hear it.
Okay, anybody else hearing the buzzing from the document camera? It shouldn't be buzzing. Yes, still hear buzzing. But, okay, and go ahead and hit enter on your feedback, and a little feedback on the camera. If the buzzing is really silent, really quiet, that'd be good to know, or if it's really loud too.
It's not distracting. I could barely hear it, but I don't believe it's distracting. At least for me, it isn't.
Okay. And when I close the document camera, does the buzzing then go away? Even the quiet buzzing?
Yes, it does.
Okay. All right. And then it goes away. All right. Good. All right. Let's go back to practice quiz. 2 problems with percentage. Do numbers 3 and 4. Okay, 30 seconds more. All right, so there's an intuitive way to do number 3, which is 13. All we're trying to do is to do this, 13%. 13% is 0.13. Of means multiply. So we get that. So then I just punch that out on my calculator. I get 156. Now there's another way to do it, which is translate word for word. What number is x, is equals, and then 13% is 0.13. Of means times, and 1,200. And then we get the x being 156. Either way, we get 156. Okay, and then the second way of translating word for word might be more helpful with this next one. What is x? Percent means divided by 100. It also could mean move the decimal 2 places to the left, but since I don't have it in a decimal form, I can't do that with a variable. So I use the definition of per is divided by cent is 100. Of means times. What percent of 20 is means equals 14. So then I'm going to rewrite this 20 over 100 and put the x next to it equals 14. Now, I like to reduce my fractions as soon as I see them. Divide by 20, divide by 20. 1/5 x is 14, and then I'm going to multiply both sides by 5. The 5's cancel, x equals 50, 60, 70. Now, what percent of 20 is 14? We're claiming that 70% of 20. So thus, 70% of 20 is 14, and I can check that. 0.70 times 20. And when I multiply that out, I do get, punch it on my calculator, I do get 14. It checks. Okay, and 3 and 4, a little bit of feedback. If one was harder than the other, let me know. Go ahead and hit enter. I've got two problems now. Do 4 and 5. Okay, 30 seconds more. So I'll go word for word. 15 means equals 25%. I could do it as a fraction or a decimal. Of means times. What number is x? And then I'll divide both sides by 0.25. Because it's multiplied, I can't subtract it. I have to divide it the opposite of multiplication. And then punch this out on my calculator. 15 divided by 25.25 is 60. Hold it. Yeah. 60. Now, let's see if that makes sense. We're claiming that 15 is 25% of 60. But 25%, 0.25 times 60 is 15. Yes, it checks. Alright, and then number 5, we've got to get rid of these parentheses. 7x minus 2x plus 3. That minus affects both. 5x plus 3 is 23. 5x is 20. I have to subtract 3 from both sides. Divide by 5, x is 4. Alright, a little feedback on 4 and 5. And go ahead and hit enter. All right, that's it for practice quiz. Questions? Yes.
A few students had questions about on the homework 74 through 76.
74 through 76.
Yes.
And this was what section? 2.4, right? And this has to do with the calories of non-fat cafe latte are from fat. All right.
That is correct.
All right. So let's do number 74. Okay. What percent of calories in non-fat cafe latte are calories from fat? Now we look up in the charts, the nutrition labels, and now the non-fat cafe latte, we don't have this label. Oh, hold it. I can use my document camera. Yes. Will be helpful. Alright, so those who get the buzzing, sorry about that. I put in a new driver and it's not as bad as before. Alright, so we're using this chart on the right over here, and percent of the calories are from fat. The total fat percentage daily values is, we just are going to look it up, and it's 0%. And if we were doing 73, our calories from fat, we would just look it up, right? Now mine has the answers. You see it has, because I have the teacher's edition, and percent of the calories are calories from fat.
You have to use the 126.
Calories from fat way up here, and then the calories total is over here. Okay. So that's how they got that 46.3%. They used that number, 126, divided by 272. And then this one, you take the 0 divided by 168. And this is just percentage of daily value. This is different. Like how many, what percentage of fat do you need in your diet every day? And this gives you 22% of that. So it just comes from those numbers up here. Okay. Let's look at one more, like 75. One non-fat cafe latte weighs 453 grams, of which 24 grams are carbohydrates. What percentage are carbohydrates? All right, this one is just, all you do is the 24 divided by the 453. Okay, does that answer the questions on those? Anybody still have more questions on?
That answered the question for one of the students who asked me about it, so I think that answered the question.
Okay. All right. Thank you. Any other questions? All right. If no more questions, let's go to 2.4 formulas. All right. So we're getting into formulas today and how we use formulas. I think it's a pretty neat section. So the first task is draw a 3-inch by 5-inch rectangle and then find its perimeter. So if you don't remember what the word perimeter means, let me give you a moment to take a guess. Think of what it would be. And I'm going to draw it in a second as well. Alright, so 3 inches by 5 inches. Now if this is 3, this is also 3. If this is 5, this is also 5. The perimeter is the distance around the outside edge, like a fly. Started here, walked around the edge. How far did the fly walk? Well, it had to do the 5 twice. It had to do the 3 twice. And the inches are the units. Alright. Now, if a rectangle has width W and length L, what is its perimeter? So here we're going to get a formula. So let me give you a moment for this. So it might be feel a bit strange where they don't tell us the numbers. And it doesn't matter which one we decide to call the width. Some people call this the width, some people call that the width. It doesn't really matter. It's perimeter, let's call it P for perimeter. It's, well, you're going to get the W twice when you add around, when the fly walks all the way around. And you're going to get the L twice. And this is a formula for the perimeter of a rectangle. And that's how formulas come about. We abstract things and we just say, all right, let's use letters instead of numbers. And then we come up with a formula. All right. So, first use of this is using this formula, P equals 2W plus 2L. Find A, P, if W is 3 and L is 5. I'll give you a moment to stay ahead of me. Alright, so what we do here is we insert those things in here and here, so that P is 2 times 3 plus 2 times 5, which is 6 plus 10, which is 16. And they didn't tell us what the units were, whether those are inches or feet or whatever. Alright, now, this is what we call the ideal use of a formula. Because these two variables over here are what we call the input variables. The ones that occur on the right side. Of the equal sign. The one that appears alone on the left is called the output variable. And if you're given values for the input variables, there's no additional work you have to do. You just plug those in and pull out your calculator and voila, you've got your answer. You don't have to solve an equation because the output variable is all by itself. So you just do the tasks that are what you're supposed to do with the input variables, and you come up with the output variable. Now, in the same formula, find L if P is 40 and W is 9. And again, give you a brief bit of time to stay ahead of me. Again, you get more out of it if you're pushing, trying to stay ahead. And being active rather than just watching. Okay, so we go to this same formula. We come over to here. P equals 2W plus 2L. And we know now that the P is 40. The W is 9. Alright, now this is not the ideal case. We have to solve an equation now. So, well, let me go from here up to here. 40 equals 18 plus 2L. There was no work in solving the equation on number 3, on part A. But here, we've got work to do. So I get 22 is 2L. Divide by 2. L equals 11. Okay, so L must have been 11 when the P was 40. And that makes sense because if we draw a rectangle, and we have 9 and 11, then these two add up to 20, and these two would add up to 20. That would give us a total 40 perimeter. Okay. Now, whenever we have a formula with 3 variables, it works like this. The idea of when using such a formula, if you know any 2, you can find the third. But the easiest way is when the 2 that are given are the input variables. They're on the right side. There's no additional work to do. Any other combination of 2 of them, you can find out what the third one is, but you, like in this case, might have to solve an equation to find it. Alright. Let's go to part C. Solve that equation. P equals 2W plus 2L. Solve it for L. Let me give you a minute on this because this is a little more abstract. Alright, so you might be totally stuck, like what does it mean to solve for L? It doesn't mean find the number that L is, like L is 6 or something like this. All it means is rearrange the equation so that the L is alone on one side. So I look at it this way. There are 3 separate terms. 1, 2, 3. And there's only one of these terms that contains L. So I move the other term, the 2W term, to the other side. And minus 2w is 2l. Then I'm going to get L completely by itself and get rid of the 2. Since it's multiplied, I have to divide by 2. Now the 2, you have a couple choices. You can divide each term by 2, or you can put the whole fraction, the whole thing, over 2. And then when I do that, I'm going to get L equals P minus 2W over 2. The other way to do it, let me just show, if it was P minus 2W is 2L, you could divide each term by 2. And then you get L, I put that part first, and then P divided by 2 minus, now the 2's will reduce, and you just get W. Either one is fine. Either is good. Okay, whether you put it as one big fraction or two separate fractions. Alright. Now, you might wonder, well, what's the use of this? Let's suppose we stick with this equation on the left. Why would I want this thing just moved around? It's the same equation, just looks a little bit different. Well, let's now use your new equation to find L if P is 40 and W is 9. So let me give you a minute to get ahead of me there. So I'm going to take this equation right here, I'm going to write it again. When I see L, I put L. When I see P, though, I replace it with 40. When I see W, I replace it with 9. And then I put the 2 down here. And this becomes 18. So it's 22 over 2, which is 11. Alright, now that's the same answer I got for L when P was 40, W was 9. Way back over here, but here, notice I had to do all these processes. I had to subtract 18 from both sides and then divide by 2. Here, I am subtracting 18 and dividing by 2, but I get to do it in the really easy way, because I take the equation, that's the ideal equation. These two are the inputs, and there's no equation solving to do. I just compute this, and I have my result. Alright, so if I had like 100 different problems to do, and it was P is equal to one number and W is equal to another number, and find the L, I'd be way more efficient by creating this equation first and plugging them in to that equation, rather than having to solve an equation for each and every one of those 100 problems. Alright, any questions at this point? Could you all give me a tiny bit of feedback on everything's good, or I need to review something, or, you know, go a little slower, or the pace is fine? Just a little feedback on where you're at with all this so far. And go ahead and hit enter as soon as you have some feedback. All right. So now we're going to go to some specific problems. So this was number 3. So let's call this number 4. A. Solve for R. Distance equals rate times time. D equals RT, solve that equation for R. We're going to do a number of problems where it's going to be all letters. Well, it'll be a mixture of letters and numbers. And we're going to be solving for one of the letters. It takes a little while to get used to this kind of solving. We've been solving in a much different way. Alright, so I'm going to work this out. I'm going to subtract t from both sides. And what I get is d minus t equals r. But this isn't correct. It's a common error, though. I want to point it out. With r and t, they're being multiplied. We have to use the inverse of multiplication, which is division. If it was added together, then we'd be subtracting here. So we're not doing that. Let's do it correctly this time. D equals RT. We're going to solve for R. We divide like this. Alright. Now, actually, I didn't do it correct. I did another common student error. You don't divide by the variable that you're trying to solve for. But that's a common instinct. It would be my first instinct told something like this. Because what would happen in this case would be the r's would cancel. You'd get t equals d over r. But you see, this equation is not solved for r. When you're solving for the letter r, you divide by the other stuff, not by the variable itself. So we throw that away as well. Let's do it a third time. D equals RT. Let's solve for R. We get rid of the things that are next to the R. And the operation is multiplication, so we're doing the opposite of that, which is division. And we get rid of everything but the R. So the R becomes alone by itself. So I'm going to go sideways here. The t's will cancel. I'll turn the equation around. D R equals D divided by T. Let me get a sip of water here. Excuse me. Alright, finally, we have solved it. And again, when we solve these, we are not going to be getting a number. Typically, all our solvings before today have been, solve for x equals 7. We get a number. Here, solve for r, we just rearrange the equation so that the r is by itself. That's it. It's the more you go further in math, the more it gets like this. Less numbers, more we get into the abstraction about the relationship between these letters. Okay. And let's do another one. Part B, solve for y. Two x plus 3y is equal to 6. Let me give you a minute with this. Alright, so I see three terms. Only one of these terms contains the letter y. So I push the term that does not contain y to the other side. I get 3y equals. Now I could write 6 subtract 2x, but I'm going to put negative 2x plus 6. We're going to find out a little later that we like to solve these equations when it has x and y in it. We like to solve it for y, and we like to put the x's first on the other side. Then the next thing is we're going to get rid of the 3 so that the y is completely by itself. Now, the last time we did such a problem, I told you there were two ways to do it. I can put this whole side over 3, or I can take each term and divide it by 3. When we have y and x, our preference is going to be each term, like this. And then we're going to get y, the 3's cancel out. Now, the particular form that we prefer over here, we'll like it like this, where the x is at the same height as the fraction bar. Because really x is the same as x over 1, so x really belongs in the numerator, but you have the option to write it just to the side, like this. And then 6 divided by 3 is 2. Okay. And some of you may have already been exposed to this, but this is in a format y equals mx plus b, and we're going to get into that later on, where we can see what the thing in front of the x is. The m is negative 2/3 and the b is 2. Alright, so we have solved it for y. We didn't find out y is equal to a particular value or anything, but we got y alone on one side. Alright, let's take a 15-minute break. We will start again.
I have a question really quick on that last one.
Yes.
Why did, instead of like dividing the 2x, you subtracted it? But earlier you said if it's being multiplied, you do the opposite, you divide.
Okay. The 2x, how is the 2x attached to the y? It's being attached by this plus, this addition sign.
Okay.
So the different terms, they're all being added or subtracted. So then we have to subtract. And then it's the 3 that's being multiplied. So the 3 has to divide.
Okay, thanks.
That clears it up?
Yeah.
Great. All right. We will start again at 1:30. And does anybody else have any questions or need to talk to me about anything? All right, midterm grades. I just put in midterm grades today so you can see what your grade is at this point of the semester. But you can always see that because you always have the total average in Canvas. And if you're, somewhere in the 90s, that's an A, some form of an A. Somewhere in the 80s, some form of a B, etc. But you can also look up your specific midterm grade. All right, nobody has any questions? All right, then I'm going to take a break as well. Mute. Pepper, can we go down? All right, well, let's start again. And all right, so we went and we solved this equation for y, and that was b. So let's go to c. Once again, we're going to solve for y. And it'll be y plus 5 equals 2x plus 2. So, let me give you a minute. Alright, so when I look at this, I think, well, the only thing attached to the y is this 5. If I move that to the other side, I'm done. But I probably need to get rid of the parentheses too, because if I just move this 5 to the other side, there'll be a like term that I won't be able to combine unless I get rid of the parentheses. So my first step is I'm going to be getting rid of the parentheses. Distribute this. And then I need to get the y by itself. How is the 5 attached? By addition, so I do subtraction. And that's it. Alright, let's go to another one. D. I equals P R T. Solve for T. And again, you'll really get a lot more out of it if you make a guess, even if you're not sure what to do. Okay, so let's look at it. Let me go over a couple things that I've seen in the past with students doing these. Subtracting PR from both sides. And these are being attached by multiplication, so subtraction wouldn't get rid of them. Opposite of multiplication is division. Another thing, again, is I've seen students divide by t on both sides. You're trying to solve for the t, trying to get the t isolated, so you're getting rid of not the t, but get rid of everything else. So, got to get rid of the p and the r. And then t, I'll put that first. I divided by p r. Now, this is in banking. Interest equals principal times rate times time, but you didn't even need to know what the formula represented to be able to follow the instructions to solve for a certain variable. Any questions so far? All right. Next one. Now, here they're going to get significantly more difficult. ahead and solve this one for y. Okay, maybe stop. So, next to the y is a +1 and a divided by x. So those are the two things I have to get rid of to get y isolated. Now, I cannot subtract 1 from both sides to start with because that one is being divided by x just like the y is. They're both being divided by x. So, the thing I have to start with is the x. I have to get rid of the x. Now, how is the x attached to the y? By division. So how do I get rid of it? By multiplication. Now, when I multiply by x, I'm really multiplying by x over 1. Because anything is itself divided by 1. And these x's will cancel out. And this x will join the top number, or you can put it to the side, the same level as the fraction bar, like this. And then we need to get rid of the +1. So I subtract 1. And this is what I get, and this, notice, is the preferred form when it's y and x. Y equals something times x minus something else. We'll be calling this mx plus b in a little while. Alright, so it's been a little while since I've asked you for some feedback. Give me a little feedback, particularly on this last one, but how it's gone overall, and particularly on this last one. Do you need more practice on this last type? And go ahead and hit enter when you have that typed up. Okay. Well, let's do another similar to this. Yeah. So for y, let me give you a little bit of time with this one. Alright, so I'm going to get rid of the 2 and the x so that y is all by itself. But I have to get rid of the x first. It's being attached by division, so I multiply. That's really multiplying by x over 1, not x over x. And these x's will cancel out, and I'll get y plus 2 is negative 1/2, and I'll put the x at the same level as the fraction bar. And then I'm going to subtract 2, and I get y equals negative 1/2 x. Subtract 2, that's solved for y. Alright, and that is the finishing up this type of problem when we're solving for one variable. That was number 4. Let's go now to number 5. Circles. I want to introduce you, since our topic is formulas, 2 famous formulas for circles. And let's, the first one is circumference. It's F. Circumference. Circumference of a circle. Now, the circumference is another word for perimeter. We only use the word circumference, though, when it's a perimeter of a circle. Same as perimeter, it's the distance around. And so we're going to come up with a formula with circle, but we're going to start with a problem. And here is the problem. And I think I'll type a little faster. Problem. Just a little bigger. You need to fence a circular pond. Now the reason why you need to put a fence around the circular pond is this is in a park, and the water has got all kinds of algae and crud growing in there, and they need to shock the water and kill all these living things in this pond. And so first of all, they before they put a whole bunch of chlorine or something in there to shock it, they got to make it safe, and they hire you to put a fence. And you're going to put it right at the very edge of the water. All right. Now, you visit the pond, and you bring a rope. And you figure, we'll just bring this rope around the edge of the pond, and that'll tell us how much fence you have to go purchase. And immediately from visiting the pond, you're going to go to Home Depot to purchase the fence. All right, but when you get to the pond, you find that your rope is only long enough to go across. It goes exactly the right distance across. The distance across the pond is 10 feet. So you were hoping that your rope would go all the way around the edge, but it didn't. The rope only went across. This is 10 feet. And you've got to go and you're going to have to make some kind of guess at, you're going to buy a fence that's 6 foot high. How much 6 foot high fence do you purchase? Like, if you only purchase 10 feet of this fence, it's not going to go around. How much do you wind up purchasing? So I don't want you to do any fancy arithmetic or anything like this, but I want everybody to go into your group chat and everybody just type in a number. Make a wild guess. How much fence would you buy for this? And we'll examine some wild guesses and we'll see if we're kind of close to the answer. We're kind of just looking at our instinctive reaction now. So we're not interested in really being right. We just want to find out what's our instinct in something like this. If 10 feet goes across, it's 10 feet across, how much around the outside edge? And group leader, make sure you let your group know who's the spokesman for the day. And I'm going to ask each group to just tell me all the different numbers that they see entered in. So we'll just take some kind of wild guess. 10 more seconds. All right, group one. What kind of guesses do you have?
Hi, I'm the only one here in my group, and it's Kylie, and I don't know. I don't know.
We'll put a question mark. All right, group two. Group two, how much fence would you buy? Do you have any numbers?
Yeah, it's only two of us today. 60.
60 feet. Okay. Group three.
Our guess is the same, 60 feet.
60 feet of fence. Group four.
Maybe, this is Randolph, maybe like 30 feet.
30 feet of fence. Do we have a group five in this class? Group five?
Yes, we do.
Okay. And is anybody got a number for group five? All right, we got 3 guesses. Let's go with that. All right, so 2 of these guesses are going to give us extra fence, which is kind of a nice, because 60 feet is well more than we need. And if you only wanted to make one trip and make sure you had enough fence, 60 feet would do it. 30 feet might do it, might not. We'll have to see. All right, so what we're going to do is we're going to imagine we took this rope that went across the pond and we laid it, we stuck one end of it right here, and then we laid it along the edge. Now, when you lay it along the edge, it'll go further than this quarter of the way around the circle. But it certainly won't go all the way around up to here, because that's the shortest distance between 2 points is a straight line. It'll go about to here. So when you lay this red rope around, it'll go about that much. And then we take this end, we anchor this end, and we bring this end around, and we lay the rope along, and it'll wind up going to about here. And then we anchor this end down, and we grab this end of the rope, bring it around, and we lay it carefully down, and we bring it in. It will almost return us back. It'll be a little bit short. And 3 times the diameter is almost the circumference of a circle. But you need a little tiny bit more. Does anybody know what that little tiny bit more is going to be? How much more of that? Instead of just 3, you needed 3.14159. You needed pi. So the diameter times pi is equal to the circumference. Now this is true no matter what size circle you have. And this has been known for thousands of years, that if you take even a little tiny circle and you look at the distance across, and you lay that distance across about 1/3 and 2/3, about 30, and you're not quite there. And it doesn't matter the size of the circle. The diameter times pi, you need a little more than 3 of them, and you'll get the circumference. Now, the diameter, so we can call this thing D for diameter. You can also call it twice the radius. The radius is from here to here is r. The radius goes from the center of the circle to the edge. The diameter goes all the way across the circle. Okay. So if you replace the diameter with d, you'd get d times pi equals the circumference. But if you replace it with 2 times the radius, and then the circumference is c, and then we turn this equation around, we put c for circumference first, and then we get 2 pi r. This is the famous equation for the circumference of a circle. This is the circumference of a circle equation. All right. Any questions? Is this making sense, or does this seem too theoretical? All right. No equation.
No, it makes sense.
Yes.
It makes sense. It makes perfect sense.
Okay. All right. Good. All right. And look back at our guesses. These were very reasonable guesses. The 30 feet was pretty close. If we take pi, now the radius in our particular case for the pond, the diameter was 10 feet. So the radius is half of that, 5 feet. So circumference is 2 pi r. And we're going to replace pi with 3.14. It's an irrational number. It goes on forever and ever, but we approximate it with 3.14. And then we'll put 5. Now the 5 times the 2 makes 10, so it moves the decimal over one place. 31.4 feet. So, both answers were great answers because 30 feet was really close. But 60 feet is like you know, if you actually bought 30 feet, came back, and then you're 1.4 foot short, you might be really frustrated. You got to go back to Home Depot, come back again, and then go back again. So 60 feet would have been just, you made sure that you had enough, and then you return the rest or whatever. And all right, now that's one really famous formula for circles, circumference of a circle. And it's one that you're supposed to memorize. So I want you to take a moment and commit it to memory. C equals 2 pi r. In a little while, I'm going to ask you to repeat it from memory. So make sure that it's C equals 2 pi. But we're going to go to, now that was circumference of a circle. We'll call that A. All right. B. A real brief introduction into area. And let's take the area of a rectangle first, and then we're going to take the area of a circle. Area of a rectangle. If I have a 2 foot by 4 foot rectangle. Now, I made it look like 2 inches by 4 inches, but imagine this is representing 2 feet by 4 feet. Kind of like the tiles. I have tiles on my in my house floor that are about 1 foot by 1 foot. And this would, when you find the area, you're really just finding out how many tiles there are going to be. So here would be a marker for 1 foot, and for 4 feet you mark it up like this. And so if we just come across, we say, all right, how many tiles are there? And there's either 2 rows of 4 or 4 columns of 2. Either way, it's the area equals 2 feet times 4 feet, which is 8. And then notice feet times feet is feet squared. What we often call it is 8 square feet. Where a square foot is one of the tiles. That's 1 foot by 1 foot. Alright. So that's the area of a rectangle, and if we generalize this, suppose we have any rectangle, either one can be called the length, either one called the width, doesn't matter. The area of any rectangle is equal to the length times the width. Alright, now that's kind of talking about area in general. You're trying to find out how many squares there are inside of something. So let's go to the area of a circle. And let me take, now this would be handy if I had an XY grid here. So let me change over because I think I have an XY grid available. No, it wasn't in that class. Or maybe it was in my college algebra class. Let's look there. Yeah. But it's here and I have an XY grid. Alright. Yeah, let me take this XY grid right here. And so I have my grid, and let's suppose I have a circle, and it is radius. Here's going to be the center of my circle, right here, and it's going to be radius 2. So it'll go out 2, 2, 2, 2. Draw my circle. Let's go. So r equals 2 is the radius. And we're going to find out a formula for the area. Now, if I tried to get the area of the circle, one way to do it is to just count up how many squares. I got these 4 central squares, but all these other squares are partial squares, and it's going to be kind of hard to estimate how many, but I would guess maybe, I don't know, 6 or 8 total squares inside there. But what I can do is this. This has more area than the circle, because it's a square that contains the whole circle. The area of the square is, well, we can count up all the rectangles inside there. 1, 2, 3, 4. 4 rows of 4, or 4 by 4. Which is 16. Okay, so there's 16 squares inside that. So we know the area of the circle is less than, is less than 16. Okay. Now, let's compare the area of the circle to r squared. The radius is 2, so it's 2 squared, which is 4. Now, 4 is the area of one smaller square, right here. The area of the circle is, let me show you, let's use the math symbol. It's clearly less than 4r squared. When I use r squared, I get 1/4. And when I do 4 of those, it gives me the area of the big square. And that's clearly more than the area of the red circle. So the area of the circle is less than 4 of these r squareds. But if you take 3 of these r squareds is larger than 3 of those r squares. 3 of those is not enough. But 4 is too much area. It turns out the area of the circle is how many of these r squared? Anybody have a guess as what number goes here? It's somewhere between 3 and 4.
Would it be 3.14?
That's exactly it. It is pi. Pi r squared. And now we have 2 formulas to remember. The circumference is 2 pi r, and the area is pi r squared. And notice something that's pretty remarkable about these 2 formulas. On the right hand side, it's the same 3 characters. There's a 2, there's a pi, and there's an r. They have exactly the same 3 symbols on the right hand side, but they're just arranged differently. And if we were going in inches, circumference would be measured in inches, but area would be measured in square inches. And so r is the one that would have the units on it. R might be 2 inches, or r squared would be then 4 square inches. So it's easy to remember which one goes where. The one where the units are squared is area, and the one where the units are to the first power is the circumference. So these are the 2 formulas related to a circle. Area and circumference. So what I want you to do now, study those 2 formulas for a moment. Look away and write them both down from memory. And then look back to check, see if you have them right. Okay. And some of the homework problems you might have, where you might have something like this. So I think that was, what was this? This was all number 5, so number 6. They might just tell you something like this. Here is a circle with diameter 10. And it might ask, find the circumference. Right. When you're asked to do one of these problems, what I highly recommend is you don't look up the formula. You guess what the formula is first, and then you look it up to see if you did it correct. So I'm going to guess the formula. Circumference equals, I know, oh, the 3 characters are 2 and pi and r, and it's not r squared because that would give me an area, so it's 2 pi r. Write down the formula from memory, then I look it up, oh yeah, I got it right. And then we take this, if the diameter is 10, the radius must have been half of that. The radius goes from the center to the edge. So we just plug in our 5 here, and then the circumference would be 2. We'll substitute 3.14 times 5. 2 times 5 is 10. It moves the decimal 1 place over, 31.4. And that would be it. And that finishes us up for today. Your homework is 2.4 formulas Last time you did 2.4 percentages. Now it's same section, but it's the problems that relate to formulas. And any questions? Okay, we will stop here. I'm going to stop the recording.